Okay, great. So, let me clicky. This says, for each of the 4 parts of the experiment, write an equation using the 2 variables and a proportionality constant. So for part 1, P would equal K times V if direct, and P would equal K over V if inverse. So part 1. What we're really doing is we're solving for if these are inverse or direct. Now, what I like to do is I like to solve actually for K, because I feel like that makes way more sense. Oh, that's calculating, but I'm saying, okay, it's fine. So for part 1, what's P going to equal? K times V or K over V? Part 1. That was Boyle's, right?
Yes.
So part 1, P equals K over V, right? Yes? Part 2. Part 2. So part 2 was which one? You're going to have to look back and tell me what that was. Temperature and pressure. Was that direct or inverse? That was direct, right?
Yeah.
So that was going to be, what was it? Volume and temperature? Is that what that one was?
It was pressure and temperature.
So temperature, this would be pressure, this would be, it was temperature?
Yeah.
Yes? So T equals K times V, because that's direct. Yes? 3. So do 3 and 4 really quick. Do 3 and 4 very quickly. Which one was 3? Was that? That was, I thought that was 2.
No,
2 is temperature and pressure.
Oh, so this was actually 3, the one we just did.
no. Pressure and temperature were in part 2. And
Yeah, but we have temperature and volume for part 2.
oh,
So we'll just flip it.
yeah.
So P equals K times T, right? Yes. And then 4 was what? Pressure and number of molecules? Yes. So P equals K times N, which is also known as Avogadro's number. So we could calculate K for all these. We're not going to do it. But if I substituted in a P and a V from your first trial, I'd get a number. And if I substituted a T and a V, I'd get a number. A P and a T, I'd get a number. A P and an N. We're not going to actually do that. But what that would prove is if I solve for K, right? So K would actually equal on this one, let's see. I would multiply, K would actually equal P times V. Yes? Agreed? If I solve for K. This one, K would equal T over V. This one, K would equal P over T. And this one, K would equal P over N. P over N. Agreed? Do those look familiar? Those should look familiar. Okay. So, based on the mathematical relationship that you obtained in step 1 above, for this, combine all 4 variables into a final equation. So, get your notes out. We're going to do this together on the notes. You might see where I'm going with this. Okay? So get out your notes. This is actually kind of cool. So this is what we proved in lab. So let's actually do this on the notes because I want to make sure that you guys have this. First of all, Dalton's law of partial pressures. This has nothing to do with anything, but I want to make sure you guys have this. So all his law is P total. So the total pressure of something is equal to pressure 1 plus pressure 2 plus pressure 3, dot, 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 dot. So Dalton's law just says add up the individual pressures and they equal a total. Cool? Cool. So back to the lab. So on the first one, it looked like this. You had pressure, you had volume, and it was an inverse relationship. Agreed? This is how pressure and volume looked. So if I made this into an actual inverse relationship, okay, it would look like this. P, and I would have 1 over V. Are you guys okay with that? If I wanted to make this linear. And that would look like this. Agreed? These are the same graph. I'm just manipulating it into a straight line. Yes? Why would I manipulate it into a straight line? What can I do to a straight line that I can't do to a curved line? I can calculate the slope of it. So we know that y equals mx plus b. Yes? So on this one, this would be y equals mx plus what? What's my y-intercept? 0. So if I solve for m1, m1 would equal y over x. Agreed? Are you with me so far? Basic algebra. Which would equal P1, yes, over 1 over V1. Are you guys okay with what I just did there? M2 would be the same. This would equal P2 over 1 over V2. Everybody with me? If I solve for M1 then, M1 would actually equal, if I divide by a reciprocal, I actually multiply by the, if I divide by a fraction, I multiply by the reciprocal. So M1 actually equals P1 V1, right? And M2 equals P2 V2. Does that look familiar? Whose law is that? Boyle's law. So Boyle's law is P1 V1 equals P2 V2. Boom. Guess what happens for pressure and temperature? Here we go. Here's pressure. Here's temperature. Here is M1. Here is M2. We know that y equals mx plus b. So what would M1 equal on this one? M1 is going to equal y over x. Agreed? What is y over x going to be on this first one? P1 over T1. I think this is actually cool because you learned this freshman year. You learned this in Gen Chem, but you never actually see why or how they were derived. What's M2 going to be? M2 is going to be P2 over, right? P2 over T2. What is Gay-Lussac's law? Gay-Lussac says that P1 over T1 equals P2 over T2. Yes? I'm going to flip my page because I'm out of room. Do we need to keep proving these or do you guys get it? You get it, right? Can I flip my page? Okay. So next law that we did, we kept pressure constant, right? So on that one, the graph was volume and temperature. It went up, right? Whose law is that? Charles watches TV. So Charles' law is V1 over T1 equals V2 over T2. By the way I taught this freshman year was Boyle plays volleyball. Gay-Lussac watches TV. Remember that? And then, no, Charles watches TV. Gay-Lussac drives a PT Cruiser. Gay-Lussac drives a PT Cruiser. That's how I remember those. Or you just know them at this point. And then the last one we did, the new one, was pressure and number of molecules, which was also a direct relationship. This is called Avogadro's law. It's a direct relationship, so it's going to be P1 over N1 equals P2 over N2. Are you with me? So for the first one, we said that K, I'm going to move this down a little bit. We said that K equals P times V. This is back from our lab, right? Yes. For the second one, we said K equals P over T, the constant. For the third one, we said K equals V over T. And for the fourth one, we said K equals P over N. If I would sub all of those into 1, what would K equal? K would equal P times V, agreed? Also P times V. P times V over what? What's going to be at the bottom? N and T over N times T. Guess what K is actually equal to in chemistry? K is actually equal to R. If we would have taken real data points from our lab and subbed them into here, we would have solved for R. Guess what R would have equaled? 0.08206 liters times atmospheres over moles times Kelvin. That is how they figured out the ideal gas constant. So the ideal gas law, if I rearrange it, the ideal gas law we know is PV equals nRT. Pressure is observed in ATM, volume is observed in liters, moles is observed in, N is observed in moles of particles, temperature is Kelvin. What people usually miss on this is this, okay? They forget to change Celsius to Kelvin. And we know what R is. Isn't that kind of cool how they actually came up with that? You basically just did it in the lab. Are we going to do the math to do that? No. There's one other law you may see. P1 V1 over T1 equals P2 V2 over T2. This is called the combined gas law. That is all three of them not accounting for number of moles. Cool? Sweet. So for the lab, I know we have the pictures, but it was such a pain. Let's just put our name on the packet, turn that in, everyone's going to get full credit. How's that sound? Boom. All right.